So let's get right into it. So now we're going to do a similar set of calculations, but this time for strong bases and weak bases. And there's just one extra step we need to make in doing both of these types of calculations compared to the strong acid and weak acid examples. And that's highlighted right here. Okay, so we remember Kw equals H plus times OH minus, which is 1.0 times 10 minus 14. Okay. And we're going to find the OH minus concentration from either a Rice table, or in the case of a strong acid, it's just used directly, right? The initial base concentration is the same as the hydroxide concentration. And then we're going to take this Kw value, 1.0 times 10 minus 14, divided by the hydroxide concentration. Then that gives us the H plus, which we can then use to calculate pH. Okay, so let's see how that shakes out. So calculate the pH of a 0.05 molar solution of sodium hydroxide. All right. Well, we know that the OH minus, automatically, I'm just going to write that that's 0.05 molar, right? Directly, just from this relationship right here. Okay. So now, if I were, there's a couple different ways I can do this, and I'm going to demonstrate all of them. So if I were to take the negative log of that 0.05 molar, that's going to give me the pOH. And so let's do that calculation. So that's 0.05 log. And then, of course, we remember the negative sign. So we know that our pOH equals, that's going to be 1.30, okay? And so I'll remind you, there's a formula that we had back here that says, let's see, here it is, pH plus pOH equals 14.0. So that's one way we could do that. So let's write that down, okay? We could say pH plus pOH equals 14.00. So then we know that the pH is 14.00 minus the pOH. We calculated our pOH to be 1.30. So I'll just do that in my head. Hopefully you could see now that that's going to mean the pH is 12.0. And that makes sense because this is a base. We should be getting an alkaline pH, meaning a pH greater than 7. And so our answer makes good sense. Okay. Well, what's the other way that we could do it? Well, we could say that H plus equals, I'm going to write this formula down, 1.0 times 10 to the minus 14 divided by the H plus concentration, divided by the OH minus concentration, and that's 0.050. Okay, so let's do that calculation. So I've got 1 times 10 to the negative 14, okay? And I'm going to say divided by 0.05 equals, and so there, with 2 sig figs, that's going to be 2.0 times 10 to the minus 13 molar for H plus. And then now I know that my pH equals the negative log of H plus, which means the negative log of that number, 2.0 times 10 minus 13. And so I'm just going to leave that in the calculator and just push log. Oops. Let's try it again. So let's say 2 times 10 to the negative 13. Okay, good. And log. Okay, beautiful. And so we remember the negative sign and the negative sign cancel. And you can see that worked out to be 12.70 with 2 decimals as significant digits. So both worked out the same way. You can do the calculation either way as long as you do it correctly. Okay, the next example, we'll do a weak base calculation.